Today we're going to talk about doing calculations with molar mass. We're doing this so that in future classes we'll be able to determine what mass of one chemical will be produced from the mass of another chemical during a reaction. And our success criteria is to be able to convert between mass and moles using molar mass. So calculations with molar mass are pretty straightforward. If you've studied physics already, it looks very similar to a velocity formula. Molar mass is equal to the mass of an object divided by the number of moles present. So we can calculate the molar mass for a chemical. If we know the mass and the moles, we can calculate the mass if we know the molar mass and the moles, and we calculate the moles if we know the mass and the molar mass. The units in molar mass are really important. So molar mass's variable in a formula is capital M. Its units are grams per mole. Mass's variable is lowercase m. Its units in this case are grams. And moles, or chemical amounts, symbol is N, and its units are MOL. We don't actually write out mole or moles because MOLC is the abbreviation for molecule. And sometimes we do have to talk about the number of molecules present. So we just use MOL as the unit for moles, and we usually just call it mole as well. The units in molar mass are really important because anytime you have something per something else, it's not just units, it's also a ratio. If you have 12.01 grams per mole, the molar mass of carbon, what that means is it's a ratio of 12.01 grams for every 1 mole. Or you can write it as a fraction, 12.01 grams over 1 mole. Ignore the fact that math teachers would hate you for putting a decimal in a fraction. We do it in chemistry all the time. What that means is we can reverse that. We can actually change that number from 12.01 over 1 to 1 over 12.01. Now that might seem like it's counterintuitive, that you shouldn't be able to do it, but you can the way we use molar mass in chemistry, because what we're doing is we're not changing the number. Obviously, 12 over 1 and 1 over 12, if that over means division, are two very different numbers. But we're talking about 12.01 grams over 1 mole, or 1 mole over 12.01 grams. Even though we're writing it as a fraction with different numerical values, it's really a ratio. And all that we're changing when we flip it upside down like that is we're changing which one we're comparing first, the 12.01 or the 1. The reason this is important is we can use it in something called unit canceling. Unit canceling is a way of eliminating units, just like we would eliminate numbers or variables with cancellation in math. We all know 2 divided by 2 is equal to 1. 3 divided by 3 is 1. 9,817 divided by 9,817 is still 1, and I can pick any random string of numbers as long as it's over the same number, it's always 1. You can do that with infinitely large numbers, but you can also do it with units. If you take moles and divide by moles, you get 1, which cancels the unit out. So if we divide grams by grams, we can cancel them out and remove them from the equation. And the reason that this is important is because this allows us to solve these problems without using the formula. We do give this formula of big M over little equals little m over n in Science 10, but I'm going to teach you how to do it without needing that formula at all. All you have to do is look at the units.